In section 2.5 we're looking at graphs of f of mod of x and mod of f of x. Now we've actually already dealt with mod of f of x, that is if you've got a graph, back in 2.1 we looked at this, if you've got a graph, well that's f of x. If you then take the modulus, that means anything that's negative make it positive, doesn't it? So anything that's negative make it positive, so cross off anything under here and flip it in the x-axis. Now if you're not quite sure why, then go back to section 2.1, look at the video on it, and or look in your textbook, get the idea of what the modulus is. It means ignore the minus sign, anything that's negative make it positive, so that's why we get that shape. What about f of mod of x? Well, let's say we've got a graph here. That means take mod of, so this is the graph of f of x. How would that change into mod of x? Well, that would mean before you put the number into f, take the mod of it. So positive numbers don't change, do they? So positive numbers have the same mod as the, mod of 2 is 2, so that's fine. So all of this stuff would look the same. What about this number here? Well, take the mod of it. Well, say this is minus 2. Mod of minus 2 is 2. So we'd put that in, and above minus 2 I get this number here. So I wouldn't get, everything that's to the left of the y-axis wouldn't exist. What I would get would be this stuff here reflected. So if you have mod of f of x, cross out anything underneath the x-axis and reflect it up here. If you have f of mod of x, cross out everything to the left of the y-axis and ignore it, and reflect this stuff here over to the negative bit here. Okay, so that's how we get our mod graphs. Combining transformations in section 2.6 is just telling us, those GCSE transformations, we know f of x plus a and so on, f of x plus a slides things to the left, f of x plus a slides things up. Sorry, well, when I say to the left, if a is positive, it slides to the left. If a is negative, it slides to the right. If a is positive, it slides up. If a is negative, it slides down, and so on, right? So you need to know those ones. You need to know f of ax, f of x times by a minus f of x, and f of minus x. We need to know all those transformations, and guess what? They still work, even if you've got moduluses, sine functions, all the rest of it. Back at GCSE, you had questions that would look like this. So you have a function drawn for you, and you get told the coordinates of this point and the coordinates of this point, and they say, okay, this is the function f of x. So let's say, for example, this is the point 4, 5. If I do f of x plus 3, where does this point end up? And you go, well, x plus 3 would slide it to the left, 3 spaces, so you sketch it, of course. That's where the graph would end up. I know it's gone 3 spaces that way, so it's still at a height of 5, and it's gone 3 spaces, so it's at an x coordinate of 1 now. Okay, so that's the sort of question we get asked. They are questions you've seen before, but now there are going to be nastier functions in there. There's going to be mod functions in there, and all the rest of it. But there isn't much to add in terms of new maths. It's putting together things that we have seen before. Section 2.7. And you see I'm skipping through 3 things here. We spent a lot of time thinking about how moduluses work, how functions work, and now we just get to apply it in different places. Solving modulus problems. Now really what this is about is, well, look at the example. The questions they ask you, they can ask you, it doesn't just have to be moduluses, it could be anything. State the range of the function, okay? Any function that you've drawn, when you've got the graph of it, look at it, what's the range? Well, the range is all the y values that get used. So if you've got a function that looks like this, then what are the y values that are used? This number and higher, okay? If you've got a y value that looks like this, what are the y values that are used? This number here and higher. And obviously our modulus functions look like v shapes. If I do the modulus function and then take away something, I can slide the v shape down here. If I put a minus sign in the right place, where would the minus sign have to be? Well, reflect it in the x-axis would be a reflection in the y direction, so that would be an outside the brackets thing, so I can end up with an upside down V shape by putting a minus sign at the front of everything. There is a video, if you flick back to the graph transformation stuff on in the first book, there's a video in the AS or the Year 1 core playlist which will run you through how these things work. So I'm not going to go over that again here, but that puts us at the end of chapter 2.